Okay, so we're going to try a different form of video here, and we'll see how it works. I am going to use a tablet, and we'll go from there. We're going to also use Microsoft Office and use OneNote and see how far we can go. So today's lecture, we're going to talk about what's going to be on the test real quick. I'm going to try and do these in 15-minute videos so that I can post them both on Canvas and on my YouTube, and we'll see what happens. Hopefully this is much better than what we've been using. I think it is anyway. So let's talk real quick about Test 2. Test 2 is next Wednesday, and it's going to be from 9 a.m. to 12 noon. And again, don't forget that you've got to have enough stuff to, you need to make sure that you can do all this stuff and get it to me in the correct time frame. If you don't, then I probably won't give you any credit for the test. And make sure that you have all of your pages in there and that I can see them. So things like stuff. The first question's going to be stuff. I would review the old test. And I would review the sample test. My handwriting sucks, but that's okay. I shake too much. Things like, I would say you're going to have to collapse a network, and that network's probably going to be, it could be a strictly a resistor network. It could be a I don't know what's going on here. Why did that even come up? I guess because I touched it. Sample test, resistor network, or a capacitor network, or an inductor network. Not a combination of any of those. It will just be either a resistor network, a capacitor network, or an inductor network. I would tend to think, since it's me and I'm a little odd, I would tend to think it's going to be a capacitor network. You should also know how to do voltage divider, current divider, what's a Thevenin equivalent, network, those types of answers, all the stuff that you have on things you should know all those things. There'll also be a power problem, where it's supplied or absorbed, a DC power problem. That will definitely be on the first question. So you should be pretty good with that stuff. 2, nodes, a node equation. 3 is going to be a loop equation. 4 is going to be an RLR, an RC, and like I said in class, I will want you to go step by step basically, but you'll be looking at things like what the circuit looks like at those points. So at t equals 0 minus, inductors look like a short circuit, capacitors look like an open circuit. T equals 0 plus, you can replace a capacitor with a voltage source. and an inductor, or an inductor with a current source, because current can't change instantaneously in an inductor, voltage can't change instantaneously in a capacitor. So you're looking for those types of networks. Then when you go to the T equals infinity network, the capacitor looks like an open circuit again, the inductor looks like a short circuit. So those are the types of things that I will be asking exactly what you look at on the sample test. You'll see that that's exactly what we're looking for. So, and that will show up exactly like that on the test. Not the same problem, but those types of questions and how to answer them. Last but not least will be number 5. It will be an RLC network. I suggest that you look at the sample 2 test, problem 5, and you know how to find VO of T and IO of T in all those resistors. I think you'll find that I have a very good, on the sample test, you were looking for IO of T across that 6 ohm resistor, and on the homework, you were looking for VO of T across that 6 ohm resistor. So you have a 1 ohm resistor, a 4 ohm resistor, and an 8 ohm resistor in that problem. Also, you should be able to find those two across any of those resistors in any orientation. And it's should be fairly straightforward. I would also say that you want to be sure that you either have a printout of all the pages that you need, all the cheat sheets, all the step-by-step methods, all the stuff. You might also want to have all of the homeworks out. You should be making pictures, or having some type of hard copy of your homework, maybe, if you can, or on your computer so you can just go right to it, bring it up. How did I work this problem? Because this problem is a lot like this problem on the test. Again, you can use any resource you want on the test except for your fellow students. I would appreciate you not using your fellow students. But I have no control over that, and that's up to you guys. So those are the things I would have ready to rock and roll to take the test. This should give you a very good idea of what I'm going to ask. So if you have questions, or you want me to go over something like the homework on a video, I can do that now that I kind of know how to do this stuff. It's still a learning process for me. I'm still stressing out, but that's okay. Let's maybe talk about the labs too. I'm having some trouble with my lab TAs. I think y'all had either 4 or 5 labs. I think it was 4 labs. So I have grades for one lab, no grades for the other lab. And starting next week, I'm going to post videos, lab videos, virtual videos of 3 labs. We're going to do take a tour of the central utility plant. We call it CUP. We're also going to look at a solid dielectric switch, 25 kV. And we'll also look at a 25 kV to 480 volt transformer. And I will have some questions, a couple of questions, not many, a couple of questions for you to look at and answer if you have a problem figuring out. Actually, this is ER. If you have a problem figuring something out, you can always send me an email and say, hey, what the heck's going on with this stuff? And I'll gladly throw a video up or something like that to help you guys out. And ladies, sorry. And so if you have a low grade in the lab, I'm also going to not enforce the 70% rule. I will enforce the 70% rule for homework and tests, though. But for the lab, I'm not going to enforce the 70% rule. So if you have a low grade, I wouldn't worry too much about it, because the last 3 labs, you should be able to pick your grade up quite a bit. Anybody with, you should be able to score 100 on them, really and truly. But if you just say you had 60s on the first 3 labs and you had 90s on the last 3 labs, basically you have a 75 average, so it shouldn't be a problem. The higher you make on the labs, though, the better overall grade you'll have in the class, just saying. So I'll be sending those out next week. I'm going to try and start doing these 15-minute videos pretty quick. My only problem is I might run over because I talk too much. All right, so if you have questions about this, again, look at the video, point out the time, and send me an email with the time on it, the time stamp on the video, and I'll try and answer any questions that you have. So one last thing before we go, I'm just going to hit a little bit of AC. There will be no AC on the test. The only thing on the test will be DC and the transients. So again, we have that pocket of information. We have Ohm's law. We have voltage divider. We have current divider. We have KVL. We have KCL. We have mesh, loop, superposition, and we have source transformation. God, that's a long word. And then we have Thevenin. And if you like Norton. Source transformation is exactly going from the Thevenin equivalent, which is a voltage source in series with an impedance, to Norton, which is a current source in parallel with an impedance. So, source transformation, you just throw them back and forth. Superposition is unique for AC. If you have DC components and you have different frequencies of AC components in a circuit, then superposition is the only way it will work. Multiple frequencies. So if you have multiple frequencies, superposition is the only way to go. You work the problem, put one frequency in, solve for that solution, whatever it might be, put the next frequency in, change all the values, solve for that solution. And so that's the only caveat, I guess. And the other caveat is power. In DC, 14 minutes and 24 seconds. So I'm going to stop this video now, and we'll continue this on the next video.